Ladies and gentlemen, here we have a capacitor start, capacitor run single phase induction motor. You can see this is the starting capacitor, and here we have the run capacitor. And I just wanted to show you how it is connected inside here. We've just repaired this motor, and but you can see the supply is brought in here, and this is the actual connection of the capacitor. Actually, what we did first, we had to remove all of these nuts here, and we tested between U1, U2, Z2, Z1, and Z2, and we found, just to find out which one is your running winding and which one is your starting winding. So the starting winding is normally the one with a higher resistance, and the running winding is the one with a smaller resistance. So we found that our main winding had 4.2 ohms and our starting winding at 5.8 ohms, right, which was between Z1 and Z2, and our main winding was between U1 and U2, and the centrifugal switch, which is normally closed when the motor is at standstill, which is V1 and V2. So what one should also note here is that the starting capacitance is usually the one that is higher. You can see here the motor starting capacitor. This one is about 150 microfarads, and this is basically because when you're starting the motor, you need a high torque, and when you need a high torque, that translates to a high current. And in order to have a high current, you need this XS to be very low. And in order for this to become low, that means your starting capacitance here should be very high. That's why we have a high capacitance here. And for the running capacitance, we can say that I don't have pen. For the running capacitor, it's still the same. XR equals to 1 over 2 pi F CR. And you can see now this running capacitor should, during the normal running phase, you actually require a lower current than during the starting. So that's why when this one is low, right? So when this one is low, that means you require a higher XR, right? For this to be high, the capacitance of the that's in line when running needs to be very low, right? That's why you have low farad ratings there. So we have connected this up according to this. Once we have identified our U1, U2, Z2, Z1, we have wired this up. As you can see, our live wire, our brown wire is brought at this point, which is connected at U1. This is U1, U1, U2. This is V1, V2. This is Z1, Z2. All right. So this Z2, we put a bridge piece here to connect Z2 with U1, and then we just put our live wire there. And at the other end of Z2, the other end of Z2, which is Z1 here. Here, Z1, we connected our capacitor, our running capacitor, as it shows here also, right? And then from there also we connected V1, as we show here, our centrifugal switch, by putting that bridge piece there. All right, and then the other side of that centrifugal switch, which will be V2, this point here, we connect our starting capacitor, and we can see all the other 2 points of those capacitors. You can see in this drawing, all these points are brought to the return, which is our blue wire here. All the other points are brought there. So it doesn't matter which ones, the polarity of these capacitors, it will not affect your starting or running circuit, so since these are unpolarized capacitor. And you can see that mostly this the run capacitor is of a high time capacitor. The timing, it's since it's in the circuit, it's continuously there, and this one is a short time capacitor, which is actually the starting capacitor is mostly electrolytic, and the run capacitor is mostly put in some paper. All right, so that's it about the motor, and we have tested it and we ran it and it tested fine. Okay.